Hey GQ, I'm Dr. Jordan Nguyen. I'm a biomedical engineer, inventor, and futurist, and this is The Breakdown. In this episode, we'll be breaking down robots and future tech. Iron Man.
You're going to start off nice and easy. You're going to see 10% thrust capacity, achieve lift. And 3, 2, 1.
I love that scene. Just the way that Tony Stark goes about designing the thrusters to his suit to allow him to fly. He just goes straight in and tests it. What I loved about seeing these movies was I was going, he designs things the way that I do. He tests them out, he crashes them, he hurts himself in some cases. In university, when I was doing my PhD, I was designing a wheelchair that could be controlled by the power of the mind. The wheelchair itself was a robot, so it needed to be able to see and think for itself. The first time I got my wheelchair to operate, I didn't think anything was working. I didn't think I had the program controlling the motors yet. So I started eating my lunch, I sat back in my seat and I ran the program to see what would happen. It took off, and not only did it take off, I had the voltages completely wrong. It also took off at a fast speed, threw my screen off the table, unplugged itself when it took off towards the wall, but not in time. It actually went through the wall of the office that I was in. And then when Iron Man came out a few years later, I started realizing he was designing things the way that I did. And this is all part of it. You design, you test, you usually try not to hurt yourself like that, but then you iterate.
3, 2, 1.
We'll pause it right there. I love the detail they've gone into in this scene. So exoskeleton technology is something that's always advancing. Exoskeletons being able to wear some sort of suit that can help you with strength, or can even help people who might have a spinal cord injury or not be able to say move the legs, be able to stand and potentially walk. I've seen all kinds of exoskeletons getting smaller, cheaper, lighter, faster. They operate a lot better than they used to, and they'll eventually get to the point of being able to just wear suits as well, wear some sort of outfit that looks like a lot more like a material. In this case, he's got this metal exoskeleton. He's trying to take on that next level of iteration in his flight. He's trying to control it a lot better. The level of detail that they've got in this scene is just awesome, because we've got even those little side thrusters that help stabilize his legs as he's taking flight. I think that was just amazing level of detail that they've paid attention to.
We should take another look into arc reactor technology.
Oh, come on. The arc reactor, that's a publicity stunt. Tony, come on, we built that thing to shut the hippies up.
We'll pause it there. So this arc reactor, it looks very much like a hydrogen fusion tokamak, and even Jeff Bridges' character there, Obadiah, he's saying it's a publicity stunt. It's almost a take on where hydrogen fusion is at and what's happened in the past. It was always touted as being the energy of the future and always will be, or the energy that will be 30 years away and always will be. So there is a big international collaboration called ITER, I-T-E-R, and this is where many countries have come together to try and realize this potential future energy of hydrogen fusion. Different to nuclear fission reactors, where you're breaking apart isotopes of something like uranium or plutonium. In a hydrogen fusion reactor, this kind of works the way that the sun almost creates energy itself. You've got a donut shape, and that donut is a vacuum. And so they push a hydrogen gas into that vacuum, and it's surrounded by electromagnets. So magnets with huge amounts of energy going into it to try and contain and hold that charged gas in place so that it doesn't touch the sides, because they heat it right up, and they can heat it to a plasma that gets to about 150 million degrees Celsius. We're talking 10 times the surface temperature of the sun here. And To get to that level of heat and pressure, what happens is hydrogen atoms start actually fusing together. They convert into helium, there's a drop in mass and a massive release of energy. And you can see here in the arc reactor in this scene, it has a big donut shape, so it's got that tokamak style shape to it. It's even got little rings which look like they're the electromagnets. But in a tokamak, the way it tends to look is they just tend to look like a giant dome. And it really is a holy grail of energy generation, so this is why it's been in the movie, and the arc reactor resembles that. Ex Machina.
You're wrong.
So this is chilling scene. It's an amazing movie. It's a modern take on the Turing test. So this was designed by Alan Turing in 1950. The whole idea was that a person would interact with an artificial intelligence in the future at some point where an AI could sufficiently dupe a human into thinking they were interacting with another human. If they could be sufficiently duped, then the Turing test would be passed by this advanced level of artificial intelligence. Now this has come up over different points in time, like Ridley Scott's 1982 Blade Runner. The androids in that movie were tested with something they called the Voight-Kampff test. And this test was to try and bring out levels of empathy. They would look at the eye, they would look for pupillary dilation, so the response that the android would have to being given emotionally evocative questions. Whereas Ex Machina has taken this to a whole new level, and this is what I absolutely love about this movie. Caleb here is speaking to what is clearly an android. They're not hiding that. So what is happening here is it seems that Ava knows that she's sentient, that she's cognitive, that she's actually uniquely experiencing her environment, and that she's conscious. She's trying to convince him of that fact. At this particular point in time where AI becomes somewhat sentient, when it can exhibit that level of human characteristic where it's able to perceive its environment, interact with it, learn independently, but also show that level of sentience, of self-awareness. Well, even though it's not biological, this will start to bring up a level of robots and AI rights, because who are we to say that a robot or an artificial intelligence can't love, can't experience these levels of emotions? Because once it's able to properly trick us into believing that it is sentient, this raises a massive set of ethical questions that we have to be able to answer. Do AI systems, whether they're in robot form or not, will they need rights?
Do you think I might be switched off because I don't function as well as I'm supposed to?
Eva, I don't know the answer to your question.
A robot or an android like Ava is so advanced, it would be built in a way that utilizes a fusion of many different types of sensors and at the same time trying to replicate those of humans and the artificial intelligence, many types of artificial intelligence interoperating. So Ava is able to see out her eyes, it seems. It seems like she's utilizing cameras and the same sort of image processing technology, but at the same time, when it comes to artificial intelligence operating through camera technology, it could actually be used to perceive a lot more than, say, the human eye. There could be infrared in there as well. It could have infrared sensors, so she might be able to even see in the dark, who knows. Then there would probably be haptic feedback, so she'd be able to feel things like if, say, a person was touching her hand, she would be able to feel that. So to try and emulate the types of sensory systems that our body has, it's very, very difficult because our body is just full of so many different sensory systems, sensory input, and then be able to output through movement, through voice, through gestures, through human characteristics and mannerisms. Very complex technology, massive fusion of many different types of technologies from hardware to software and artificial intelligence, but these are where the advancements are all headed. The technology is pretty much all there. It just needs to be designed in a way that's streamlined, so it all works together seamlessly and can all fit, including the power systems, can all fit into an Android body. But the technology is well on its way. WALL-E, oh, I love this movie. We'll stop it there. What this animation does so well is depict a robot that has so much personality. Now, this is called anthropomorphism. It's where we project human personalities and characteristics onto things that aren't human. And we do this all the time. It's why you might say name your plants or see a face in the front of a car. This is what we tend to do. We project human personalities and characteristics onto things that aren't human. This whole idea of how much we like an entity or a robot or an animation, it doesn't matter what type of entity it is, but how much we like it depends on how human-like its characteristics are. And this is called the uncanny valley. As an entity, as a character, becomes more and more human-like, our affinity for it goes up. We start to like it more and more, up until a certain point. And then there's a point in time where an animated character or a robot becomes too human-like. And what happens is we plummet down the valley, and this is called the uncanny valley. We actually become scared of it. We become a bit freaked out. And that's what happens if you see an android that's been designed, a robot that looks very human-like but isn't quite right, because our brain is able to pick up on those tiny things, the microfacial features, all the different changes, the things that we're suddenly missing out on. We can see it's an imposter, and our threat detectors go off in our brain. The only way to come out of the uncanny valley is to make something so human-like it's indistinguishable from the real thing. This is a principle that's used a lot in animations and movies that I think the likes of Pixar and DreamWorks just get so right in how they do these things. WALL-E doesn't look at all human, so it's not along the curve of the uncanny valley. We're not going to get freaked out by it, but it shows lots and lots of human characteristics in his personality. He's curious, he's interested, he's creating his own little space where he's got all of the different gadgets and toys and things that he's picked up in his travels that he enjoys. We're seeing him have a bit of a love for life, and that's giving us joy through being able to see it. Because so much of that personality comes across in those small things, those small details like the look of the eyes, the way that they move, the imperfections like WALL-E has. There's perfection in imperfection because we actually like things that aren't perfect. It happens a lot. When we're watching these things, we don't want to see everything that's completely symmetrical, completely perfect. Our brain likes those levels of imperfection. And this comes across in the personality of something like a robot, which is why my robots also get distracted and have that level of curiosity. AI, artificial intelligence.
His name is Teddy. Teddy, this is David.
Hello, Teddy.
Hello, David.
David, Teddy is a super toy, and I know you'll take good care of each other.
I am not a toy.
I love that. I am not a toy. The movement in his eyes, the facial expressions, it's what I'm saying. You're able to bring across personality. This whole movie is a modern take on Pinocchio. David is a young android boy who's been designed to replicate the son of this family. They've lost their son, so they have an android replacement. And so he's basically like Pinocchio. He wants to become a real boy. He wants to become a real human. At the same time, Teddy is basically Jiminy Cricket. Teddy is the voice of reason for David and goes on these adventures with him, always sort of working through what he should be doing, what he shouldn't be doing, helping him on that journey and being his guiding light. The robots all form some form of function that can, in many ways, help humans. So you've got the boy, David, who's been designed to help in that grieving process so that the family can have a replacement. Whether that completely works or not, it depends on how people obviously deal with grief. I think that we are going to see various levels of robots augmenting the human experience. It's never meant to replace human-to-human interaction. That's not what it should be for. We get a lot of amazing benefits in having face-to-face interaction. Our brain loves and thrives on face-to-face, real-life interactions. Our brains physiologically change each other in each other's presence, particularly when we make eye contact. iRobot.
Yeah, I know. The 3 laws, your perfect circle of protection.
A robot cannot harm a human being. The first law of robotics.
Yeah, I know. I've seen your commercials. But doesn't the second law state that a robot has to obey any order given by a human being? What if it was given an order to kill?
Impossible. It would conflict with the first law.
Right, but the third law states that a robot can defend itself.
Yes, but only when that action does not conflict with the first or second laws.
You know what they say? Laws are made to be broken.
So these 3 laws of robotics have come up in this movie. It actually was originally created by Isaac Asimov, and that's why they're called Asimov's 3 laws of robotics. Now these actually were built into his short story called Runaround, which he wrote in 1942, or published in 1942. And this had and featured the 3 laws, which he also built into his fictional robots in many of his other stories as well. And this is a governing set of laws that are built into robots so that they will help humans, they will improve humanity and not become our enemy. So they're kind of like safeguards that have been built into all of these fictional robots, but also basically brought up this whole concept that we need to think about when it comes to artificial intelligence and robotics, that we need to build in these safeguards. We might need to build in things like the 3 laws. The problem with it though is that these laws tend to be very subjective. They can be open to interpretation, and you don't want robots or AI being able to interpret rules or laws because it could potentially find ways to work around it while still satisfying it. So laws will probably need to be made a lot more specific in this particular case.
My father tried to teach me human emotions. They are difficult.
This brings up a much broader conversation about artificial intelligence. This is an area I've gone into in my book. It's been widely philosophized, this area in the future, this point in time, the technological singularity, where artificial intelligence becomes on par with human brain in every way possible. We're currently widely acknowledged, we're currently placed in the artificial narrow intelligence band out of 3 major areas of AI. The next is artificial general intelligence, and we are a general intelligence because our brain is incredibly complex. It can do so many different things. We are able to learn various different tasks. We're able to adapt to our environment. And when an artificial intelligence becomes on par with us in every way possible, it becomes an AGI, an artificial general intelligence, and it will very quickly, by that point in time, be able to take itself to the next level. It will be able to evolve itself to become an artificial superintelligence, where it goes beyond human capacity and we suddenly end up with a new alpha species. So at this point in time, things could get really, really bad for us, or it could get really, really good. And this is going to be based on how we approach this particular philosophical point in time. So really what Isaac Asimov did was he put into our minds that we need to be able to build values, build laws, build things into an AI so that once it gets to that point, it will actually want to create benefit for humans, for life on Earth, and maybe even help us do things like explore the stars. So there could be mutual benefit in it, but we need to be able to plan for this before we get to that point. Back to the future.
Does it run like on regular unleaded gasoline?
Unfortunately, no. It requires something with a little more kick. Plutonium.
Plutonium. Wait a minute. Are you telling me that this sucker is nuclear?
Hey, keep rolling there. No. This sucker's electrical. But I need a nuclear reaction to generate the 1.21 gigawatts of electricity I need.
Doc, you don't just walk into a store and buy plutonium.
Stop there. That's right, you don't just walk into a store and buy plutonium. Plutonium isotopes are often used in nuclear reactors. Plutonium and uranium are the main isotopes used for nuclear fission, which is where the isotopes are actually broken apart by neutrons being fired at the atom to split it up, which releases energy and releases more neutrons to continue on the reaction. As far as a nuclear reactor is concerned, it's more or less almost controlling a nuclear bomb. It's almost controlling that explosion, but pulling out the energy. In this case, what they're doing is putting a nuclear reactor that runs on plutonium on the back of the DeLorean to power the flux capacitor, which is what makes time travel possible in these movies and allows the DeLorean to time travel.
Watch this, watch this.
Pause it right there. The DeLorean, beautiful machine, and what actually happened here was the late Ron Cobb, he was a mate of mine, he was a political cartoonist and also a sci-fi cartoonist. He was given the task of trying to turn a DeLorean into a time machine. He said once they figured out where the flux capacitor went, everything else fell into place. The original design only had one exhaust. In this, there's two exhausts. The second one to balance it out and also make them a lot larger, which gives it a lot more balance, and the car looks incredible for it.
What did I tell you? 88 miles per hour!
I own a DeLorean as part of my production house. It is the coolest thing. It's a lifelong dream. First thing I noticed when I got in the DeLorean was it actually doesn't go up to 88 miles on the dial. They had to fix that up into this particular DeLorean for the movie. Back to the Future 2.
What the hell was that?
Taxi cab.
What do you mean a taxi cab? I thought we were flying.
Precisely.
All right, Doc, what's going on, huh? Where are we? When are we?
We're descending toward Hill Valley, California at 4:29 p.m. on Wednesday, October 21st, 2015.
Stop it right there. 2015, unfortunately we didn't get flying cars by this point in time. They have come up in some form, but they don't look the way that they did in the movies. I would much prefer a flying DeLorean to what has actually turned up. I've gotten in one of them, which was a passenger carrying electric autonomous mega drone. It had one seat, it had a thing that was like an iPad in front of you. You selected where you want to go, and this would take up through the clouds straight to the location and straight down. I didn't go very far in it, but I got to experience it, and this was in a quadcopter configuration. So this was a lot like the quadcopters that you might, fly with cameras on them, but bigger. As we just saw in this particular clip, it's a very challenging thing to fly a car. I mean, what sort of height is it flying at? He's going into oncoming traffic, a big challenge for any design to flying vehicles. So the mega drone that I got inside, to allow these to viably fly from one place to another autonomously, they set up different heights. So instead of it being like different lanes on the road, these will actually fly at different heights so they can avoid collisions that way. But there has been an iteration, and any engineer, any inventor will not only design a particular solution, they'll start to iterate on it as well. And so I love seeing that in these movies where Doc Brown comes back at the end of the first movie and it flows into the second. He's got this new design on the DeLorean. It no longer runs on plutonium because it wasn't a viable solution. He's got some futuristic version of nuclear fusion instead. So he's got a Mr. Fusion on the back. They don't show how it works, they just show Mr. Fusion on the back of the DeLorean. Doc Brown throws some soda and some scraps into it, so biological waste, and somehow converts that into energy. Now, fusion is more of a futuristic technology. It's one that is being developed, has been developed for many years. In particular, hydrogen fusion is the one that's being looked into, and it could be a future source of clean energy. Wild, wild west.
The collars around our neck seem to contain powerful magnets. As long as we can outrun the blade, we'll be fine. Gordon, how long does it take a magnet to lose its power? About 400 years. Damn!
Both of these characters have these magnetic discs around their neck, and they're being chased by these blades. So the blades would be temporary types of magnets. They're probably made of something like iron, which can become magnetic when exposed to a magnetic field. So in this, the magnetic field is being created by these rings around their necks, but not viable to create that level of magnetism. That would require a power source, which they clearly don't have on their neck here, so it can't really be an electromagnet, and it would also require a lot of power. This movie is very much a steampunk style approach to things. No battery source, no power source that would power something that would require astronomical amount of energy to create a magnetic field that strong that could pull these blades towards them. Another potential approach would be supermagnets using superconductors. Superconductors need to be brought down really, really cold to cryogenic temperatures to allow the resistance in the conductors to basically disappear, and then it can create huge amounts of magnetism. In this case, again, it wouldn't be strong enough. It's not viable for it to work this way, but it is a funny saying. As we've seen through a lot of these different clips in these movies, science fiction has given us these amazing ideas of where the future could go, and often they are dystopic. They tend to show us these darker depictions of where the future could potentially go. So we can treat these things as warnings. You know, we've got to treat them as warnings for where the future could go so we can think about them, create a better vision for a better tomorrow, and move towards those. When it comes to automation, robotics, artificial intelligence, incredibly powerful technologies that are central to our day-to-day lives, but also will be massively defining towards our future. We need to, as individuals, as groups, as collectives, as organizations and companies, be able to shape that change. So that's why these conversations are incredibly important. To be able to have these conversations, to work through what we want, what we don't want, the ethical approach to designing these powerful technologies, and how they might be able to augment the human experience, help humanity, and move towards improving all life on Earth. Thanks so much for watching these clips with me. Stay tuned for part 2.